But sometimes you get something like this inside that. So the auto software will pick that as well. So that is why the X-ray crystallographer should have common sense that such a peak cannot be a peak, it is a spike that accidentally the X-ray beam has reflected from somewhere and it has given you that spike. So when you select it within the software like this and say delete, click delete, it will come up to here. But if you say the same delete here, you select here, it will not jump to here, but it will come slightly like this. Right? So this is the difference between the spike and the peak. So when you say select peaks, the software automatically labels you 3, 4 like this. Now it depends upon you that up to which intensity you consider it a peak and up to which intensity you consider it a background. For example, if the peak starts like this, so here it is background, it is not a peak, but its intensity is comparable with that. Right? So all possible precautions should be made that what you are measuring is the real data coming from your sample. The uniformity of the peaks, the sharpness of the peaks, the spikes on the peaks, all these things should be removed. In the old days, there used to be a software called Traces. When I studied my PhD, in those days, that software was very popular, and probably that was one of the very few softwares available in those days. People used to do things manually in those days, right? Before me. At our time, the Windows just started, and people developed different softwares for electron microscopy and X-ray diffraction. So the Traces used to have you would have to select peaks, click on the select peaks. So it used to select all these peaks. Then manually we used to remove the spikes. Then there was an option that up to which intensity. So if you say that select peaks where the intensity is above 100, then these peaks will not be selected. Only this and this will be selected. But if your intensity is 50, for example here is 50, then you will lose this peak and only these peaks will be selected. So it is again your choice, right? Once you have done that, then you get a set of 2 theta angles in degrees. In science, never forget the unit. If you forget the unit, you are failed. Because science means measurability, and measurement is not possible without units. So never consider that the teacher understands it. If I write theta or I don't write degree. If I write a degree, if I write angstrom, and if I don't write, the teacher or the evaluator understands. No, the teacher and evaluator is looking into your responsible behavior. That are you responsible enough? For example, if instead of angstrom there is nanometers, and I presume it angstrom, so what a big blunder it will be, right? So never forget the unit. Then okay, when you selected these peaks, then you order it to make list of the peaks. Or there are softwares which labels them in terms of the interplanar spacings. 4.1 angstrom, for example, 3.5 angstrom, 2.4 angstrom, like this, are some label them in nanometers, right? So you got this. If the material is well known, then you can convert it into HKL indices as well. If you say, instead of these spacings, give me HKL indices, so it will give you 1, 0, 0, 1, 1, 1, 1, 0, 2, or 1, 0, 4, whatever it is, right? In this way they also give you, but when the material is known. So when you order it, you label it, and then you ask for the list in the form of table, then it gives you this table. 2 theta and I over I naught. So in both forms are given. Sometimes even some of the ICDD cards give the intensity in the form of I, not in the form of I over I naught. And GCPDS cards were in the old days. GCPDS cards used to be used for the identification of analysis of phases. GCPDS cards were in the form of books, and you will have to take your list of 2 theta angles, peaks and intensities into the laboratory, X-ray laboratory, where there used to be databases and databases in the form of those books, and you will have to look into each book. So when we used to go to the X-ray room in the evening, many people used to be sitting, opening the books and comparing their data. It was a very time-consuming job. But 2 theta you got, for example, 10, and here you got 1.28, and the intensity was I over I naught was 50, then at 15.2 degree, you got 4.6. And the intensity, for example, 100, then take 30, 33.3, you got Sura Pakar to the 33.31. Another system? Huh? If you are using, huh? If you are using copper K-alpha radiations, then the XRD. So 33 roundabout, you will see 3.34, for example, something. Similarly, 40, you will get 1.19. This intensity will be 37. This will be, for example, say 20, right? So you will get a set of 2 theta angles, interplanar spacings, and I or I over I naught. Now your job is to look into the relevant ICDD cards. ICDD cards gives you A, E, C, alpha, beta, gamma. These are only angstroms, theta, these are degrees. Crystal system and space group. Then these lists, 2 theta, these spacings, I over I naught. and unit cell volume like that, right? So you have more than 100,000 cards. So you are not going to look into each and every card. But if your material is, say, barium titanate, then you will have to look into all the compounds of barium titanate. For example, for silica, there are more than 10 polymorphs of silica. Quartz, tridamite, how many others? Qsite, in which the quartz grain was cracking at certain temperature. Alpha quartz, beta quartz, right? There are more than 10 different crystal structures of SiO2. So if you have BaTiO composition, TiO3 composition, there are all possibilities that different phases may form because you have not tied each and every atom of titanium with barium and stopped it not to go near the oxygen, right? All the phases, as I taught you in phase transformation, that all the phases which are energy-wise more feasible will preferentially form in the material. So there is possibility of all the phases. But if your composition is exactly stoichiometric barium BaTiO3, then you should look into first BaTiO3. If the BaTiO3 diffraction pattern was like this, and the standard data also look like this, because nowadays when you doing things on the computer, the software also give you the standard plots as well. So you can match your plot with the standard plots. You can superimpose them and you can measure them. But if the beta BaTiO3 plot is like this, and your plot has a little bit shouldering line here, or a little bit shouldering line here, or peak broadening or something like that, then this means there is something else there, right? So when the pocket appears like that, this means there is something else, right? And don't take it as this. Maybe you are missing the most important result you have got during your research. So never ignore these things. I can easily deceive you that if this is up to 50 and I increase this angle and this peak will sharpen and it will become like this, you will not be able to see that shoulder. But always try your best to divulge the maximum information you gain from your data. This, for example, was the 50 peak. So it is not must that the peak you get in your experimental data should be of intensity 50, right? But if the next peak, for example this one, it is 100, then this 50 should never be higher than the 100. The 100 should always be 100 if your data is matching that phase. The 100 should always be 100. And the 50 can be 55, it can be 45, it can be 52 or 53, but it will be proportional to the intensity of the standard data. If that proportionality is lost, this means there is some problem either in your experiment or the phase is not that phase. So what does you see when you interpret your X-ray diffraction data? You see that all the observed peaks and their relative intensities matched ICDD card number this for barium titanate. So you are not saying that only the interplanar spacings were matching. The interplanar spacings as well as the intensities. And make sure that 100 intensity cannot become 50 and the 50 cannot become 100. But the 100 will be always 100 and the 50, 40, 30 or lower intensities can slightly go up and down, but they must be proportional. If the 100, for example, this is 111 and its intensity and the ICDD card database is 50 and this is 100 for example and its intensity is 70. This 70 can be 75 or 80. It can be 65 or 60, but it cannot be below 50. Similarly, this 50 can go up to 55, but it should not cross that. If the camel appears high, why not the sheep? If the camel's height is, for example, 3 meters and the sheep height is 1 meter, then if the camel appears is 3 meters and your sheep also appears 3 or 4 meters, then the question comes that if the sheep can grow that much, why not the camel to further height? So if this peak is moving higher, why not the others? So there must not be loss of logic in the interpretation of data. The first question which people will ask you that if this peak has grown higher, why not the others? Right? But the most important thing which comes